Welcome to this explainer. Okay, let's just dive right in, shall we? If you're joining us, you're likely already familiar with the incredibly high-stakes environment of offshore installations, FPSOs, and, explosive gas atmospheres. But today, we aren't just looking at the technical standards. We're looking at you. We're mapping out the specific, highly structured career ladder that every single certified X design engineer climbs. And listen, this isn't some theoretical concept. This is the exact step-by-step pathway to achieving ultimate design authority in quite literally one of the most rigorous engineering disciplines on the planet.
Think about this quote for a second. Every certified X design engineer working offshore today started at the bottom of this exact ladder. I absolutely love this because it's such a powerful reminder. The path to becoming a recognized, competent person, the actual person whose signature clears a multi-million-dollar offshore platform for operation, it's not a mystery. It's totally achievable, it's strictly defined by international standards, and hey, if you're engaging with this material right now, you are already stepping onto the very first real rung of it.
So you don't just magically teleport to the top of this ladder, right? You start at step 1 as a site technician. Then you move up to step 2 as an inspector or installer. From there, you elevate to step 3, the design engineer. And finally, you reach the ultimate prize, step 4, the competent person or design authority. Each of these rungs builds directly on the one right below it. I mean, you can't effectively design a system if you don't know how it's physically put together in the real world. So let's break down exactly what happens at that foundational level.
All right, rung 1. This is where most people actually enter the field, site technician work. You're out there installing and inspecting X-rated equipment under supervision, usually backed by your X01 through X04 certifications. Now, why is this rung so absolutely critical? Well, because this is where you build that physical, hands-on instinct for what correct actually looks like on real hardware. When you're out there wrestling with heavy armored cables, sealing barrier glands, and checking flame paths, you're developing a gut instinct that literally no classroom or textbook is ever going to give you. You're learning how these components feel and operate in the harsh, messy reality of an offshore environment.
Moving on up to rung 2, let's see how this all builds. You've got the dirt under your fingernails, you know the hardware inside and out, and now you move toward design and specification. This is where that CompEx X14 certification becomes your main target. And crucially, where the standard EN IEC 6079-14 becomes, well, very personally relevant to your daily life. This massive standard dictates the design, selection, and erection of electrical installations in hazardous areas. So it's no longer just about how to bolt the box onto the bulkhead, it's about why that specific box was chosen, how it interacts with the entire system, and making absolutely sure it meets all the rigorous legal and safety frameworks.
So the big question is, what does competency under IECC 6079-14 actually look like in practice? Well, it requires a really robust mix of skills. You need general electrical engineering knowledge, obviously. You need engineering drawing literacy, meaning you've got to be able to read and cross-check complex P&IDs without breaking a sweat. You need a deep knowledge of the standards, like understanding the exact, precise differences between Zone 0, where an explosive atmosphere is continuously present, versus Zone 1 or 2. And importantly, you have to master selecting the correct X protection methods. You need to know exactly when to specify an XD flame-proof enclosure, an XE increased safety terminal box, an XI intrinsically safe circuit, or maybe an XN non-sparking motor. You're the one making these critical calls now.
Now, what's really interesting about this is what separates a highly skilled site technician from a true design engineer, and that is mastering standard IEC 6079-10-1. Before you can even begin to select equipment under Part 14, you have to understand Part 10.1, which entirely governs the classification of the hazardous areas themselves. We're talking about understanding ventilation, the specific properties of the flammable materials, the lower and upper explosive limits, and ignition temperatures. A real design engineer doesn't just glance at a map of zones, they understand the exact physics and engineering principles that define those zones in the very first place.
Okay, but before we get too carried away with all this theory, I need to issue a massive reality check. Logged field hours matter just as much as past exams. I literally cannot stress this enough. There is not a single training course in the world, including this one, that can substitute for logged, verifiable field hours. Becoming a recognized responsible person under these IEC standards requires demonstrated practical competency over a long period of time. Passing a multiple-choice test or a practical assessment in a cozy little training booth, that's fantastic, but it's really only half the equation. Think of this whole dynamic like becoming a chartered engineer or, say, a licensed architect. Passing the exams gets your foot in the door.
It proves you've got the intellectual capacity and the foundational understanding of the standards. But it's the verifiable track record of offshore project work, the actual designs you've drafted, the installations you've supervised, the mistakes you've caught and corrected out in the field that actually earns you the stamp of authority. EX's certification follows this exact same maturity curve, for sure.
All right, let's do a quick knowledge check just to make sure we're all on the same page here. Imagine you've just passed your X14 exam with absolutely flying colors, but you have zero prior field experience. Are you immediately qualified to act as the sole design authority on a brand new offshore installation? Think about what we just discussed regarding standard requirements and practical competency.
The answer? A resounding no. And hey, if you answered yes, we might need to rewind a bit. Under ENEIC 60079-14, the exam proves your technical knowledge, sure, but recognized competent person status demands a demonstrated practical track record. In the real world, right after passing your exams, you'd typically work under the review of a senior design authority. You'd be the one drafting the documentation, selecting the equipment, and classifying the zones, but a seasoned mentor would review and sign off on your work. This is exactly how you build that vital, logged track record safely and legally.
So, let's summarize your journey here. You might have started out merely reciting some acronyms, but just look at your capabilities now. You can classify zones using the point source method. You can confidently select the exact right X protection method for a given hazard. You can specify valid, certified cable and gland combinations because you know that an XD enclosure needs a specific barrier gland to maintain its integrity, right? You know how to produce the correct documentation for everything from FPSOs to mobile offshore drilling units. Ultimately, you are completely armed with the knowledge to achieve and maintain your CompEx or IECEx certification. You've got the theoretical toolkit completely locked in.
And that brings us to the end of this explainer. You have the map, you know the rungs of the ladder, and you understand the standards that govern the whole shebang. But the final step, well, that's entirely up to you. You have to take this knowledge offshore to treat every single real-world installation, inspection, or design review you participate in as a critical piece of evidence. Document it, get it signed off, go log those field hours, and go build the track record that ultimately earns you the stamp of authority. So, my final question to you is, what is your very next project, and how are you going to use it to climb to that next rung?